Okay, 2.2, limits and continuity. The first thing we want to do is talk about the limit definition. Basically, how do we understand what we are talking about when we're talking about limits as x approaches some number for a function f of x? To be able to say that it equals a specific y value coming out here like L, what has to happen is as you approach in to whatever your x value is, as x approaches that, that's what that arrow is read as you approach it from both the left-hand side and the right-hand side, you're getting close to the exact same y value. So tracing this in, what we'd want to do is see from the left-hand side and the right-hand side, those are meeting up or coming together and almost touching. Now, it's not important whether the point is actually on the graph or not. As you can see on ours, we have the open circle indicating the point's not there, only that from the left side and the right side, you're getting close to the exact same y value. Not specific for whether the point is actually on the graph or not. So let's take a look at an example here. On this one, we're looking at this graph up above, and let's first talk about approaching 1 for our limit as x approaches 1 of f of x. All right, so we're going to look at an x value of 1 and kind of trace this graph in from the left side, trace this graph in from the right side. It looks like those are coming together, and they're coming together at a y value of 2. So we'd say the limit as x approaches 1 of f of x is going to be at 2. Now let's look at the next one, part B, the limit as x approaches 2. So our x value is 2. We think from the left-hand side, from the right-hand side, it looks like we're coming together and they're going to touch. Now that point's not actually on the graph. That's a separate question that we'll answer in just a second. All right, even if the point's not there, both sides are coming together for a y value of 3. So we'd say that limit as x approaches 2 of f of x equals 3. All right, next up, let's look at as the limit as x approaches 3. So looking at 3 here, we're going to trace in from the left side, trace in from the right side on this graph. Now that point's not there at 1, but this approaches a y value of 1 for the limit. The limit is not dependent on where that point actually is on the graph. Finally, let's go ahead and look at the limit as x approaches 4. So as we trace in from the left side, getting close to an x value of 4, it looks like that y value is getting close to 2 from the left-hand side, whereas when we trace in from the right of 4, it looks like that y value is getting close to a y value of 3. So in this case, we'd say this does not exist. We cannot find that limit. Now these are different questions than what I've written off to the side, f of 1, f of 2, f of 3, and f of 4. For those, what we're doing is actually finding where the point is on the graph, if there is one. So on the first question there, let's try to answer f of 1. So f of 1 is when you take a x value of 1 and you evaluate the function at that. All right, so in this case, we're looking for the actual point on the graph. As you can see, we had a filled-in circle, meaning that point is located at 2. This kind of corresponds with the ordered pair 1, 2 being on our graph. For f of 2, a little bit different here, we look at an x value of 2. Now we don't have an actual point on the graph. It's an open circle there at the top. Up here, because it's open circle, we don't have a point on the graph when you plug in an x value of 2. Therefore, this one does not exist. Next, f of 3. Now I realize on f of 3, we're looking at an x value of 3, but we actually care where the point is on the graph. As you can see, we have this point up here again at 2 that's filled in. We're going to ignore the open circle at 3, 1, where the point is not on the graph. So in this case, we would say f of 3 equals 2. And finally, f of 4. Even though that limit did not exist, f of 4 still could. So in this case, we're looking at an x value of 4. When we plug that into the function and evaluate it, we're looking for the filled-in circle right here. That corresponds with a y value of 1. All right, hope this helps out as you're understanding the difference between limits and actually evaluating functions at specific values. Good luck.